and welcome to ResLenses. Using the 3.js library, this is an in-browser UTXO heat map visualization of transactions between addresses in the form of a physical adjacency matrix. So what exactly does that mean, and what am I looking at here? Well, as you can see, as I move my mouse around, looking at the top, there are from and to addresses that change matching the block I am hovering. From this, you can see that the X and Y axis of the grid represent addresses, and the intersections forming these blocks represents activity between two given addresses. If I were to double click on a block, it will be highlighted, and we can see the details of the transactions that occurred between the two users. So what exactly is this data and where is it coming from? For this current visualization, it is the transactions that have occurred on the ResilientDB network, but we can also view transactions on the Ethereum network, which I will demonstrate later. I'm going to hide this tooltip real fast. There's a lot of activity near the top left corner of this entire grid overall. And as you go out, you may see that there's not very much going on. You might find something here or there if you search far enough. Maybe like a block here, down here. Let's go back to the very top. That's because the addresses lining the X, Y are sorted by some criteria. By default, it is the total amount of UTXO sent out by that address. We kind of see that by looking at the first row here. This ECJ address has done several transactions, so it's the first one showing up. And then if we scroll down a bunch, we'll see that the second person has made one significant transaction as well, so they're the second. And then likewise going forward, it's going to be like that. But we can more clearly see what this looks like when we switch the view to bar mode. This essentially collapses the y-axis down to form a row of bars like a bar graph, and we can easily see the total amount sent by each address, and we can see that it deteriorates over time. First, we can see details again. Yeah, the first one is made a lot, the second one is made quite a few as well. There's actually made more, but sent out less. We can also but we don't have to sort by the total UTXO sent out. We can also sort by the number of transactions as well. Again, the first person has just made so many transactions, but the second person has also made a fair amount, 47, 14, 8, and I think after this guy, the next, all these addresses going forward have not sent out any transactions on their own. Switching back to the grid view, we can do one more modification to see how the data with this symmetry, switching back to the grid view, we can do one more modification to change up how we view this data. Instead of explaining it right away, let's just see what it does when we switch symmetry to true and backwards. So as you can see, essentially with symmetry set to false, transactions are asymmetric. If I send a transaction to you, the block representing from me to you would indicate activity, but then the block for the opposite of you to me would indicate nothing because you didn't receive it, you didn't send me anything, but I sent you something. If you were to switch to true, to and from are now basically the same. So if I were to send, in that same scenario, if I were to send you a transaction, I would see that block represented, but vice versa, I would see the equivalent transaction represented from you to me. And that's basically symmetry for the symmetry visualization on this block. Now, what you may have noticed as I switch from one to the other is there's a lot more blocks now. And that's because we've just created more value for all the nodes. If someone had not received something, they've now been a part of transaction. And if there has been two ways, that means both their transactions are now increased as well. And this will You may notice if you were to read through these carefully that the sorting may have also changed a little bit, as that new value is now accounted for when computing the sorting. Back. Earlier I mentioned that this was the ResilientDB data, but there's also the Ethereum network as well. I'll further explain the differences between the data collection of the two. For ResilientDB, this grid represents all transactions ever on the network. But as we switch to the Ethereum mainnet, which will take a second, the data there is not all of Ethereum. I mean, it would just be like too much for the backend to acquire millions or billions of transactions, all of that have ever occurred on the network. So instead, the data for the Ethereum network is a collection of 48,000 transactions sampled by 1,000 per hour for the last 1,000 per half hour for the last 24 hours. One thing you may notice immediately is that it looks completely empty for the most part. That is because the data here is just very sparse. Just by scrolling down a bunch, it would take quite a while just to find just a few transactions like this. Even more so if you sorted by transactions total. Yeah, just like one every now and then. That's because there's likely more transactions than addresses, which makes sense because each transaction attributes to 2 addresses, and if we're doing more randomized sampling, 1,000 every 30 minutes, we would get something like this. If we switch to bar mode, you can definitely see that there is a lot of activity on these first few addresses. You just can't see them as much in the grid view. And also for longer too, there's just a lot more addresses that have participated in some kind of activity. But we want to see an interesting grid as well, so what can we do? Well, there's this one last sorting method that I kind of just overlooked at the very beginning, and this is really useful for more sparse data like this. So we can sort by the largest transaction. As you may have guessed, as you can see, it sorts the blocks first and then brings forth the addresses that belong to that block. So we're guaranteed to see something interesting almost immediately. See this big guy, and then the blocks shrink as you go out, and it just brings the addresses right to the front so that you can see all the big activity almost immediately. And by sorting it like this, you get like this diagonal looking pattern as you view more of the data. But there's also one other way we can fix this sparsity problem. We can also use symmetry, which earlier I explained will bring forth more data into the blocks, or like visualize more blocks. So let's switch to symmetry to true on number of transactions, and look at that, there's already like a lot more activity just near the front. So this concludes ResLenses. A nice 3D visualization that shows us 2 different networks and a few ways that we can organize the data for our viewing pleasure. Feel free to play around with it yourself and see what other interesting patterns you can find as you look around. Thanks for listening.